All right, today we're going to be learning about radicals. So first let's look at the parts of a radical. The little number that's inside the root symbol is called your index. It tells us what type of root we're taking. The root symbol is called a radical. And then the number underneath is called the radicand. So you should already know how to simplify square roots, but we're going to review it. When we're simplifying a square root, we're looking for the biggest perfect square that divides into the radicand. So in this case, that would be 4. And 24 is 4 times 6. Square root the 4, we get 2. Square root the 6, it's a decimal, so we're going to leave it as square root of 6. If we want to simplify the cube root of 81, we need a perfect cube that goes into 81. To help you guys with your perfect cubes, and when we get here, perfect fourth roots, or perfect fourth powers, I'm going to give you guys what's called a power sheet. And you're going to have this sheet with these numbers on there. You can use this on any quiz or test, with the exception of the SOL, until the end of the year. So since we're looking at a cube root, we're going to look at our row of cubes. Is 81 divisible by any of these numbers? 81 is divisible by 27. So we're going to break this up into 27 and 3, because 3 times 27 will give us 81. We're going to use the cube root of 27, which if you're looking at your power sheet, since 27 is 3 to the third, the 3, that's the base. That's the answer to the cube root of 27. And the cube root of 3 is a decimal, so we're going to leave it as cube root of 3. In number 3, since we're dealing with a fourth root, we need to find a fourth power. That 72 is divisible by. These 3 are all bigger than 72, so they're not divisible by that. Is 72 divisible by 16? 16 does not go evenly into 72, so that means this can't be simplified, so we're just going to leave it as the fourth root of 72. Now we're going to make a little jump. This explanation is on the end of your note sheet. So go ahead and flip to the back and let's look at these. A rational exponent, if you remember from when we did number systems, what does rational mean? It means we can write it as a fraction. So rational exponents are fractional exponents. So the nth root of a is written as n with this root of a. N is the index. If we had a to the m over n power, this could be rewritten as the nth root of a to the m power. These are equivalent. N is our root. Where are the roots of the tree? They're at the bottom of the tree, so they're on the bottom of our fraction. So if we wanted to simplify or rewrite this in radical notation, since we're given it in exponent notation, this would be rewritten as the fourth root of 7 to the third power. We're going to come back to number 2. I'm going to do that one last. In number 3, we have the 6th power of the square root of 13. So even though our index isn't written there, we know that it's a 2 because it's a square root. So we have 13 to the 6 over 2 power. Can we simplify this fraction? Yes. So we're going to make it 13 to the third power. So similarly, in our last example, we're going to divide each of the exponents by 3. So we'll have x to the 6 over 3 and y to the 7 over 3. Can we simplify either of those? Yes, so we're going to make it x squared, y to the 7/3. So if we wanted to go backwards with this one, we currently have two different denominators, and we want to rewrite it as a single term. So what we need to do first is get a common denominator between those two fractions. What would be a common denominator? What's the lowest common multiple between 3 and 4? That would be 12. 3 times 4 gives us 12, so we do 1 times 4 to get x to the 4 over 12. 4 times 3 gives us 12, so 3 times 3 gives us y to the 9/12. Now that they have the same denominator, we can rewrite this as the 12th root of x to the 4th, y to the 9th. And make sure when you're rewriting these that your index is inside the little check mark part of your radical. You don't want to be writing 4 root 7 to the 3rd. That means something much different than what we have written here. So we can use this idea to help us simplify radicals that have exponents in them. So what I like to do is we have a number, an x, a y, and a z. I like to separate them into each their own radical, and then we'll put them back together at the end. So we're dealing with fourth roots, and we want to simplify the fourth root of 243. So let's look back at our power table. 243 is divisible by which one of these fourth powers? (243) is divisible by 81. So I'm going to break it up into 81 and 3. As we just saw with converting, when we have a radical, we take the exponent and divide it by the index. Well, we want to make sure stuff goes in evenly, and if it doesn't, it stays under the radical. So we want the closest number to 15 without going over that's divisible by 4. That would be 12, and that would give us 3 x's left over. So we're going to leave it as x to the 3rd. 8 is divisible by 4, so we don't need to split that one up. And then 9's not divisible by 4. We're going to break that up into z to the 8th and z to the 1st. So if we simplify here, the fourth root of 81 would be 3. The fourth root of 3 is a decimal, so we leave it as it is. The fourth root of x to the 12th would be x to the 3rd. 4 doesn't go into 3, so we leave it as the fourth root of x to the 3rd. Here, 8 divided by 4 is 2, so we just get y squared, and we have nothing left in our radical. And here, the fourth root of z to the 8th would be z squared, with our 1 left over under the radical. So then, for our final answer, we put together all the things that came out of the radical. So 3 x to the 3rd, y squared, z squared. And then all the things underneath the radical get put together. So 3 x to the 3rd and z. So these, without the radical, all went outside. And these under the radical all went inside. As you get better with this, you might be able to do it without splitting them up. So what to the 3rd power goes into 24? Here's our 3rd powers. 24 is but divisible by which one? It's divisible by 8. We're going to break this up into 8 and 3. The cube root of 8 is 2, and we'll be left with the cube root of 3. How many times does 3 go into 6? Goes in twice. Y to the 4th would be y cubed and y. 3 divided by 3 would be 1, and we have 1 left over underneath. And then z to the 7th would be z to the 6th and z. 3 goes into 6 twice, and then 1z left over. That's all for today. See you in